Imagine this. You're standing on the moon. Above you, the Earth glows in the black sky, but then you realize something strange. No radio works, no signal connects. If you tried to call home, there would be only silence. That's the reality of the far side of the moon, the half that never faces Earth. A place hidden by locked rotation, shielded by lunar rock, forever cut off from communication. For decades, scientists dreamed of exploring it, but every attempt faced the same impossible barrier. How do you land where Earth cannot see you? For half a century, no one had the answer. Not NASA, not Russia. The far side remained untouched, unreachable, a forbidden frontier of space. Until 2019. That year, while much of the world barely noticed, a Chinese spacecraft called Chang'e 4 descended toward the von Karman crater, a vast scar at the moon's far side. Engineers in mission control held their breath, because if this went wrong, there would be no way to regain contact. It would be like losing a ship beyond the edge of the map. But here's the genius move. Months earlier, China had launched a relay satellite named Queqiao. It parked itself 1 million kilometers away in a precise gravitational balance point where it could catch signals from both the moon's far side and Earth. Like a cosmic mirror, Queqiao bridged the silence. With that bridge in place, Chang'e 4 did the impossible. Its engines fired, dust lifted, and for the first time in human history, a spacecraft touched down on the moon's hidden hemisphere, humanity's first landing on the far side. And it wasn't NASA, it wasn't Russia, it was China. This was more than just a landing. It was a statement, a message written in lunar dust. The new space race has begun. Why? Because the far side isn't just mysterious, it's strategic. It holds secrets buried beneath untouched soil. It's shielded from Earth's radio noise, making it the perfect place for telescopes to peer into the deep universe. And some scientists believe it hides resources that could reshape our future, from water locked in shadowed craters to helium-3, a potential fuel for nuclear fusion. So when Chang'e 4 deployed its rover, the world was seeing more than just science. It was witnessing a quiet shift in power. While the West looked back at Apollo with nostalgia, China was writing the next chapter of exploration, methodical, steady, step by step. And here's the part most people missed. This landing wasn't a one-time achievement. It was part of a larger plan. A quest that began with Chang'e 1 mapping the moon from orbit and Chang'e 2 pushing farther into deep space. Then came Chang'e 3, placing a rover on the near side, each mission building towards something greater. Chang'e 4 was proof of concept that China could go where no one else dared. But here's the question we need to ask: why the moon? And why now? Because what came after 2019 revealed that this was only the beginning. China wasn't just landing probes for science. It was preparing for something bigger, bringing samples back to Earth, testing technologies for long-term bases, and even eyeing resources that could fuel a new era of energy. The far side landing was the spark. What follows could change the way humanity looks at the moon forever. And as we dive deeper, we'll uncover exactly what China is after, what they've already found, and why this quiet lunar quest could reshape the balance of power, not just in space, but here on Earth. When China's Chang'e 5 mission launched in late 2020, it didn't aim for the mysterious far side this time. Its goal was even more ambitious: bring the moon back to Earth. For over 40 years, no country had returned fresh lunar soil. The last samples were from NASA's Apollo missions in the 1970s, locked away in labs, studied and restudied, until there seemed to be no new secrets left. The moon was beginning to feel like a closed book. But then, on December 17th, 2020, a capsule blazing through Earth's atmosphere touched down in Inner Mongolia, carrying just 1.7 kilograms of soil and rock. Small in quantity, but priceless in value. This was the first fresh lunar material collected by humans in half a century, and it didn't come from the United States. It came from China. When scientists opened the sealed containers, they weren't just looking at gray dust. They were peering into billions of years of lunar history, untouched, unweathered by Earth's air or water, perfectly preserved since the moon's violent formation. And then something extraordinary happened. Among the grains of soil, Chinese scientists identified something the world had never seen before, a brand new lunar mineral. They named it Changesite-Y, after the Chang'e goddess of the moon in Chinese mythology. To the naked eye, it looked like a crystal, tiny and unremarkable. But under the microscope, its structure revealed a unique chemical fingerprint. This wasn't just a curiosity, it was proof that the moon still has hidden surprises waiting to be discovered. Changesite-Y joined a very short list of minerals discovered beyond Earth, a reminder that the moon is not just a dead rock, but a diverse and evolving body. But the real shock came not from the mineral itself, but from what else was found in the soil. Buried within the lunar dust were traces of helium-3, a rare isotope of helium almost absent on Earth. For decades, futurists and scientists have spoken about helium-3 as the ultimate energy source. Why? Because it could power fusion reactors, the same process that fuels the sun. But without the dangerous radioactive waste of today's nuclear technology. On Earth, helium-3 is vanishingly rare. On the moon, the solar wind has been depositing it for billions of years, embedding it into the surface soil. Estimates suggest there could be millions of tons of helium-3 scattered across the moon's regolith. Enough, perhaps, to power humanity for centuries. And suddenly, China's mission wasn't just a scientific triumph. It was a glimpse into a new kind of space race, not for flags and footprints, but for resources that could redefine the future of civilization. But helium-3 wasn't the only surprise. For decades, scientists believed the moon was bone dry. Apollo astronauts confirmed it. No lakes, no ice, no rivers, nothing. But as instruments became more advanced, hints began to appear. Strange signatures in the soil, whispers of frozen deposits in craters near the poles. Chang'e 5 added hard evidence. Its samples showed water molecules bound to minerals, tiny traces but undeniable. And if water exists on the moon, even in small amounts, it changes everything. Water means oxygen to breathe. Water means hydrogen for fuel. Water means lunar bases that don't need every drop shipped from Earth at staggering costs. For the first time, the moon wasn't just a symbol of exploration. It was looking more and more like a stepping stone for humanity's survival beyond Earth. The discoveries inside those 1.7 kilograms of soil may seem abstract, but their implications are enormous. A new mineral proves the moon still holds geological secrets. Helium-3 could one day power clean fusion reactors. Water means the possibility of permanent human settlement. The moon is no longer just history. It is becoming a frontier again, one that nations and companies will compete over in the decades to come. And this is where the suspense deepens. Because resources are never just about science. They are about control. If helium-3 truly becomes the fuel of the future, who gets to mine it? If water enables lunar colonies, who decides who stays and who gets left out? And if the moon is filled with untapped riches, are we looking at the next gold rush, but played out on a planetary scale? China's Chang'e 5 didn't just bring back soil, it brought back questions. Hard ones. Questions that touch on energy, politics, and the destiny of humanity itself. Because the moon is no longer just a place to visit, it is becoming a place to own. And now, with Chang'e 6 already launched and Chang'e 7 and 8 preparing even bolder missions, the race isn't slowing down. In fact, it's accelerating. And here's the haunting thought. If the moon really is the key to our future, then whoever leads the way there may quietly shape the fate of civilization itself. And so the story continues. Because if the moon holds resources that could change everything, we have to ask, what exactly are these resources, and how far is China willing to go to claim them? That's where we go next. The discoveries from Chang'e 5 gave China a roadmap, a reason to go back and to go bigger. Fresh soil, traces of water, and hints of valuable resources had opened the door. Now the question was no longer, can we reach the moon? But how do we stay there? That is where the next wave of missions comes in. Chang'e 6, Chang'e 7, and Chang'e 8. Each one is not a standalone project, but a carefully planned piece of a larger puzzle. Together, they form China's blueprint for a long-term presence on the moon. Chang'e 6 is the immediate next step. While Chang'e 5 brought back samples from the near side, Chang'e 6 is tasked with something far more ambitious: retrieving samples from the far side of the moon. This has never been done before in history. Scientists want to know if the far side, with its thicker crust and unique geology, holds clues about the moon's formation that the near side cannot reveal. If successful, China would once again mark a first in lunar exploration, but this time with material that could reshape our understanding of the moon's deep history. But science alone is not the end game. That's where Chang'e 7 enters the story. This mission will focus on one of the most strategic regions on the moon, the lunar South Pole. Why? Because this is where sunlight lingers for long periods and where water ice is believed to exist in permanently shadowed craters. Chang'e 7 will carry instruments designed to search for that ice, measure the environment, and scout landing sites for future missions. Think of it as a surveyor. If humans ever establish a permanent base on the moon, the South Pole is the most likely location, and Chang'e 7 will provide the map. Now comes Chang'e 8, the mission that hints at China's long-term vision. While Chang'e 6 and 7 focus on gathering knowledge, Chang'e 8 is about testing technology. One of its goals is to experiment with using lunar soil itself to 3D print building materials. In other words, trying to see if future astronauts could construct shelters directly from the moon's resources rather than hauling everything from Earth. It's a bold idea, turning the moon into a place where humans can not only land, but live and build. If even part of this works, it would mark the beginning of a shift from short-term visits to sustainable presence. These missions are not isolated. Together, they feed into an even bigger project, the International Lunar Research Station. This is a planned moon base, not just a lander or a rover, but a permanent outpost. China has partnered with Russia on the idea, and the plan is to have a functioning station sometime in the 2030s. The concept goes beyond a single building. It envisions power systems, communication relays, scientific labs, and eventually habitats where humans could stay for long durations. Some designs even imagine robotic precursors building the infrastructure before the first crews arrive. It would be humanity's first real foothold on another world. While China and Russia move toward this vision, others are watching closely. NASA, for example, is pursuing its own program, Artemis. The Artemis missions also aim for the lunar South Pole, also involve bringing back samples, and also talk about a future base. But the approaches are very different. Artemis relies on a network of international partners, the Artemis Accords, and plans to use the US-developed Gateway Station in lunar orbit as a staging point. China, on the other hand, is building its own system almost independently, with a smaller circle of allies. It's like two parallel roads leading to the same destination, a permanent return to the moon. The difference is in timing and focus. Artemis has faced delays, shifting budgets, and political debates. China's program, while not immune to challenges, has advanced step by step with a steady rhythm: lander, rover, sample return, now base preparation. Each mission builds directly on the last, and that is what makes this so striking. For decades, space exploration seemed to stall at flags and footprints. But China's blueprint suggests something different. Not just a symbolic presence, but infrastructure. Roads, power stations, labs, the beginnings of a second home for humanity. If this vision holds, the next question becomes unavoidable. When the next flag is planted in lunar soil, will it belong to China? The possibility of a Chinese flag on the moon is not just about pride. It points to something larger, a new kind of space race. But unlike the Cold War rivalry between the United States and the Soviet Union, this contest is not simply about prestige. It's about resources, technology, and long-term survival. Back in the 1960s, the goal was clear: be the first to land humans on the moon. Whoever did that could claim the ultimate symbol of scientific and political superiority. Once the US achieved it in 1969, the race effectively ended. Budgets shrank, public interest waned, and for decades the moon remained a quiet, lifeless place, visited only by robotic probes. But today the stakes are very different. The moon is no longer seen as a distant rock to plant a flag on, but as a strategic asset. It has water that can be turned into fuel, soil that may hold the key to future energy, and locations that could host permanent bases. In other words, it represents both opportunity and leverage. For China, the moon is a way to leap forward technologically and strategically. By mastering lunar infrastructure, energy production, communication, resource extraction, they're not just exploring, they're laying the foundation for dominance in the space economy of the future. Whoever learns to live off the land on the moon first gains experience that can be applied to Mars, asteroids, and beyond. For the United States, the challenge is to not repeat the mistakes of the past, to avoid being caught off guard by a rival's steady progress. That's why NASA's Artemis program exists, why partnerships with Europe, Japan, and Canada are being strengthened, and why private companies like SpaceX and Blue Origin have been brought into the fold. But there's a striking contrast between these approaches. Artemis is bold but vulnerable, tied to shifting budgets, political cycles, and complex international agreements. China's path, though slower and quieter, has shown consistency. Mission by mission, it has advanced without pause. And in the long game of building infrastructure, consistency often matters more than speed. The implications go far beyond national pride. If one nation establishes the first functioning base on the moon, it may influence how resources are shared, how territories are claimed, and even how laws in space are interpreted. We could be entering an era where the moon is not just a scientific frontier, but a geopolitical one. This is why some call it the second space race. The first was about reaching the moon. This one is about staying there. And staying means control over knowledge, technology, and resources that could shape the next century of human civilization. So when we watch these missions unfold, when we see China, NASA, and others aim their rockets at the same dusty target, it's not just about science. It's about who writes the next chapter of humanity's story beyond Earth. And that brings us back to the bigger picture. Here on Uncharted Odyssey, we don't just explore space for its wonders. We uncover the hidden strategies, the silent competitions, and the choices being made right now that will decide our place among the stars. If you've enjoyed this journey through the moon's past, present and future, make sure you subscribe, leave a comment, and join us for the next Odyssey. Because out there, beyond the silence of space, the race has already begun.